So what happens during the life cycle of a star? Some B-movies? An Oscar? A star on the Hollywood Walk of Fame? No, that's a different kind of star. I mean stars found in space, like our Sun. All stars initially form from a cloud of dust and hydrogen gas. This cloud is called a stellar nebula. Gravity over millions of years causes the dust and gas to spiral together. The particles move faster and eventually reach temperatures of millions of degrees to form a protostar. A star forms when it is hot enough for hydrogen nuclei to fuse to form helium. For more about nuclear fusion, watch this video. The star then enters a long stable period where the outward pressure of the heat generated by nuclear fusion counteracts the force of gravity. The star is now called a main sequence star, and it stays in this state for between 10 million and 10 billion years. What happens next depends on the size of the star. Let's talk about a smaller star first, one roughly the size of our Sun. Up until now, the nuclear fusion has been occurring between hydrogen nuclei, but eventually the hydrogen begins to run out. Now the outward force of fusion is less than the inward force of gravity. This causes the star to collapse inward and the temperature to increase. It becomes so hot that helium nuclei can now begin to fuse together to form heavier elements, but only as far as iron. To form elements heavier than iron requires an input of energy, which we'll explain a little later. The star now expands and becomes what is called a red giant. When our Sun becomes a red giant, it will expand to such a size as to engulf the 3 inner planets. Next, fusion of helium in the red giant will eventually stop. Suddenly, the force of gravity is greater than the outward pressure of fusion, causing the star to collapse, forming a white dwarf. No more fusion is occurring inside the star, and so the white dwarf cools down. Eventually, after many billions of years of cooling, it stops releasing heat, and it becomes a black dwarf, as cold as the empty space that surrounds it. So what about bigger stars? What happens to them? They follow a different pattern. These stars too eventually run out of hydrogen, but quicker than a smaller star would. Massive stars, as a result, have a much shorter main sequence life than smaller stars. These stars then expand to become super red giants, now full of all the elements up to iron. Eventually, fusion stops, resulting in the collapse of the super red giant. The shockwave created triggers an explosion, a supernova, producing a lot of energy in the form of heat and light, which can outshine all the other stars in the galaxy for several weeks. The extremely high temperature and pressure that exists inside a supernova enables the fusion process to create all of the elements in the periodic table that are heavier than iron. The supernova distributes these throughout the universe, so that means we're all made of stardust. One of 2 things can happen next. Either a neutron star or a black hole is formed. A neutron star is made of densely packed neutrons. Formed when under immense pressure, electrons are forced to merge with protons. A black hole is formed if the mass of the neutron star is sufficiently high to cause further gravitational collapse. A black hole has such strong gravity that even light cannot escape it. We cannot yet observe a black hole directly, but we can detect it by the effects it has on nearby objects such as stars. Now that's one star-studded life cycle.